All right. Anyone hear me? Yep, cool. Sounds good. Thank you. Hello, everyone. Thank you for coming. I know this is a very late session, and there's like a restaurant thing going on, but y'all are excited to learn about EC2, and I'm excited to talk about it. So my name's Adam Beglin. I've been at AWS for a while. I started about 7 years ago. I've done a little bit of everything from support to high-performance computing to machine learning. Right now, I'm a specialist on the EC2 team, really focusing on the EC2 platform as a whole, trying to help customers understand how it works, what sets it apart, why it's cool and interesting. And so that's why I'm excited to talk to you guys about what we've launched over the last week and somewhat over the last year or so. So let's get going. Now, there's been a lot of announcements over the last week. It's daunting even for me to keep up with it, just even on the EC2 and compute side. So we've got a lot to talk about today. But I kind of want to do something a little bit different because if I just list every announcement, it's going to be pretty boring. So in addition to kind of telling you about what we announced, I want to talk a little bit about why we built it, when you might want to think about migrating to a next generation instance, or even what you might want to use it for, or how you might want to think about a specific feature or processor or whatever it is. And I also wanted to switch up the format a bit, and I wanted to rename the talk, but they didn't let me. So I'm retitling this talk Adam's Top 8 EC2 Announcements of the Year. I couldn't get enough for top 10 because if I didn't group them together, it'd be top 50 and y'all would just walk out. So let's get started with kind of an intro for anybody who somehow has made it this far in the conference and doesn't know what EC2 is. EC2, it is at its core, most EC2 instances are virtual machines that are sitting on top of a hypervisor that are sitting on top of a piece of physical hardware. And if you go down in the Expo Center, you can see we have we have an outpost rack and some the 1 and 2U things, which I'll talk about in a minute. But that kind of gives you a feel for what EC2 hardware actually is. So it's really cool that you can actually see it because, as I'll talk about, Outposts is essentially EC2 come to your own data center. And as I'm going through all these announcements, all the things that we've launched, we have a lot of acronyms and letters and numbers and things like that. So I've built this sort of cheat sheet. Feel free to take a picture, or these slides will be online. And I think that the column that I find most interesting here is this capabilities section. So in the next year, I want to try to at least get this in our documentation, because I don't think that we actually explain what the I's and the G's and the Z's and the E's and all of these mean in our instance names, and I think we should. So I'm going to try to fix that. And in the meantime, I'm just throwing it on a slide. So we've got I for Intel, G for Graviton, A for AMD. That's going to tell you the processor, and with all of our new generation instances, we are actually using all of those, which is great. We've got the Z's for the high frequency instances. So Z I think of as gigahertz, I think is where they came up with that one. D means it has local NVMEs, so it's got local disks. N means it has better networking, and B for block storage. Also, there's E, which is usually extra memory. I don't know. I kind of made that one up. I don't know where it would be otherwise. But this is how we name our instances. This is how we think about them. We've got nearly 500 different instance types at this point, which can either be really exciting if you have very specific requirements, or it can be pretty daunting if you don't know what to pick. So hopefully throughout this talk I can help you choose which instance might be the best fit for you, or at least point you down the right path of which category or capabilities you might want to think about. And really, when it comes to choosing an instance, I like to think in terms of memory to vCPU ratios, because this is how we think about a lot of our instances. So this is, the amount of memory that a system has for every vCPU. And within a family, let's say, the C family, all of those instances, whether you're in the large or the 8x large, they're all going to have the same memory to vCPU ratio. They're just going to have more or less of those, vCPUs or RAM in that system. So here you can see, if you know what your application's memory to vCPU needs are, it's pretty easy to find, at least narrow down the families to look at. And then you can then look at the specific features of that family. And things like the P's or the U's or the T's, they're special so that we do have kind of a range of them. So they're kind of the exception to the rule here. So with that, I will start with my number 8 announcement launch that I'm most excited about, which is Outpost, Local Zones, and Wavelength. You can think of these as our edge or hybrid solutions. And these are essentially, I like to think of it as bringing AWS to you or to where your data is. So with Outposts, you can essentially take AWS and put it in your data center, your office, wherever you have your data that's generating it, you've got Outposts. Local zones, maybe you are far away from an AWS data center, but you still need a fair amount of compute. I have some customers that I've seen in the semiconductor space who are essentially using local zones like a remote data center and almost treating it like it's just in the building next door, because they can get low enough latency that they don't even need to do the special things that you would do over a WAN type connection. And then we have Wavelength, which is kind of our 5G solution. So I like to think of Wavelength as like local zones for 5G. So what Wavelength lets you do is deploy compute at endpoints of 5G networks, so that users of those networks can get much lower latency when they're using the services that you've built on AWS. So with Outposts, we now are supported in 23 regions. So any commercial or GovCloud region, excluding only the China region, does have support for Outposts. And we're going to continue to support Outposts with all the regions that we've launched. And we've announced the Spain, Jakarta, Switzerland, and India regions. And Outposts will be available in that. And with Outposts, you can use things like RDS, EBS, EC2, CloudFormation, all the services that you would typically expect are available on Outposts. And some of the new things that we launched with Outposts in the last week are the Outposts 2U and 1U instance sizes. So historically with Outposts, you got a full 42U rack. So if you have a data center with lots of power and cooling, this was great because it's gonna, essentially show up in a truck, you roll it in, plug it in, and you're good to go. You have AWS on your local network. But it's a pretty big footprint. It requires, big local infrastructure. So with the 1U and the 2U racks, they're like pizza box sizes or double pizza box. You can do things like put them in retail locations. So if you're running a store, or healthcare providers, if you're a hospital or a local clinic, you don't have a big closet with raised floors that you can run cables under. You have maybe literally a closet that you can put a server in. And these are what these smaller form factors of Outposts are great for. So definitely check those out if you have local data processing that you need, that you can't have the latency of sending it to the cloud. And then we have local zones. So in the last year, I think or so, we've launched 12 cities, and we have 3 more that are coming soon. So these are for customers who do need low latency, but maybe not quite so low that you need to be running your own hardware. Also, these are going to be much bigger than the outpost footprints that you're likely to run. So for local zones, if you're located near any of these cities that you see here, if you have low latency requirements, they're a great option. And finally, wavelength. So I talked a bit about this. Wavelength is available. We've partnered with a number of different carriers. And the one that we've announced that's coming soon is Bell, Bell Canada. So if your customers are running 5G, also latency sensitive, wavelength is really a great option. So let's move on to the next one, because these are where it starts getting a lot more exciting, at least for me, is our memory optimized instances. So we, this week, announced the X2IDN and X2IEDN instances. And there's a lot of letters after those, but that's all right. The X family is the instance family that has a lot of memory in it. So we have the X2D instances have up to 2 terabytes of memory total and 16 gigabytes per vCPU, where the X2ED has, sorry, I have to read this because I can't remember it, 4 terabytes of RAM and 32 gigs per vCPU. And the exciting thing is that these come with the latest generation Intel processor. So in addition to having all this massive memory capabilities, it's got the 3rd gen Intel scalable processor is what Intel calls it. It's also known as Ice Lake, if you're familiar with that term. And these are significantly faster than our last generation X instances, which are getting a little bit long in the tooth on the processor side. They support 100 gigabits of networking, 60 gigabits to EBS, and local NVMe storage, up to 3.8 terabytes per instance. So you have a lot of processing power, a lot of memory, and a lot of local disks if you need them. So X is great for these kind of like SAP applications, big in-memory databases, anything that is primarily memory bound, or you need to have a lot sitting in RAM ready to go, look at the X family. And here we go. The other instance in the X family that we launched is the X2IEZN. And the Z here is probably the one to remember. This is the important bit. So Z means high frequency. So these can go up to 4.5 gigahertz across all cores when they're turboing. So these, have like the fastest Intel processor in the cloud. I worked a lot with semiconductor customers who are typically license constrained, and so the faster they can finish their job and free up a license, the more cost-effective their systems are to operate. So these X2 instances with the 4.5 gigahertz processor, great options for anything that needs a lot of memory and also a lot of high CPU speed. My clicker is unhappy with me. I'm gonna switch to the next. Does this one work? Yeah. Cool. So number 6 is the graphics optimized instances. And we have a lot of new options here that are really exciting depending on your workload and what you're doing. So the VT1 instances, VT stands for video transcoding in this case. And so these use custom Xilinx media transcoding cards that are great for live streaming X264 and X265 video streams. So essentially, if you're streaming, Netflix or Twitch is a great example because we use these for Twitch for streaming. So they're significantly faster than doing this on GPU and definitely faster than on CPU. So we say 77% faster than comparable instances. There used to be, and especially if you're running on like a traditional GPU for accelerating your video transcoding, you can see delays. So I like to watch Twitch. If you ever reply to a creator or somebody who's gaming or streaming, it can be 20 seconds, 30 seconds before they see your message and reply to you. And so that latency can feel a little bit weird sometimes depending on the conversation that's happening and what's going on. So these VT1 cards, especially for Twitch, we were able to lower end-to-end latency so that this streaming things that normally took a couple of 20 seconds can happen now in milliseconds. So really great if you have video streaming applications. Our G5 instances, these are our new graphics-powered instances. So they have our G family's been around for a while. They've typically been thought of as any sort of general purpose GPU that you would need. In the past, the G family has been used for video transcoding, although the VT1 might be more useful today. But the G5 instances, they have up to 8 of the NVIDIA A10G Tensor Core GPUs. And NVIDIA's naming aside, there is a lot of potential for these cards for workloads outside of even just video. They have 192 vCPUs with them. So if you're doing anything, even let's say machine learning inference, can be a good option for these cards because they are, or even training especially, because even though these GPUs aren't typically used in the machine learning world, especially with chip shortages and challenges with acquiring GPU-based instances, these A100 Tensor GPUs are pretty capable in the machine learning front and pretty cost-effective. So definitely a good option there outside of just the normal graphics workloads that you might be used to running on the G family. And the last one that I want to talk about is the G5G, at least last one in the media world. So G5G, and remember the G after the number means graviton. So these are our ARM-based graviton instances, or graviton-powered instances. So these instances, in addition to the graviton processor, have the NVIDIA Tesla T4 GPU. So we built these primarily for things like Android game streaming in mind, because with Graviton, because they're ARM-based, most Android applications are built for ARM processors, although x86 is somewhat popular out there, but running an Android game on an ARM processor is going to be very efficient. But if you need to stream that output to a client, maybe on a computer or over a web browser or something like that, you'll need something to do some transcoding. And that's where the NVIDIA GPU can come in handy. It can also be used for machine learning inference as well, because Graviton is a very capable processor, as I'll talk about later. And that GPU is going to be much faster, especially for inference at scale, than just using the processor alone. So G5G, also an interesting instance, but more use cases than maybe you might think. And with that, I will jump to machine learning. And kind of the theme with machine learning, and as I've kind of alluded to already, we have a lot of options for running machine learning applications on AWS. And that's because the more you can get out of the CPU world into the GPU or special purpose accelerators, the faster your workloads are going to be and more efficient. And that's why we have so many options. But the ones that I'm most excited about are the ones that we've built ourselves. So for instance, the EC2 Inf1 instance, or INF1, uses a custom AWS-developed machine learning chip to do inference. And we announced this, I think, or we launched it about a year ago. But what's really cool, because it is custom designed by AWS, we are able to continue to make updates and improve the performance of these instances even after they've launched. So about mid this year, we were able to update the SDK for it, make the compiler 2.5 times, 2.3 times faster, and give you 70% lower cost per inference than a GPU-based instance. And that's up significant from when it was at launch. These Inf1 instances, they're supported by all the common frameworks people use, the TensorFlow, the PyTorch, MXNet, and we also recently added support for the Hugging Face model repository. I'm not a machine learning expert, but this is actually pretty cool as I researched it. It's kind of like GitHub for ML models, and it lets you collaborate and easily use models that have already been developed. So we use Inf1 at Amazon pretty extensively. Most of Alexa actually runs on these instance families, so it's really cool. And a great, let's say low cost per inference option. And on the other side of things, if you are training models on AWS, we just announced the TRN1 instances, or just launched them as a preview. And so these are going to give you the best price performance in the cloud for machine learning training, and give you lower time to train, so they'll be faster than the latest GPU-based instances. So we're going to use, or they support all of the common frameworks. They are deployable in these massive clusters so that you can get up to 800 gigabits per second of network throughput on a single instance. They have 8 gigabytes of local NVMe storage, so that you can do things, like natural language processing, object detection, image recognition, all the things that you want to do for machine learning training can happen on these instances. And because we have a custom developed AWS chip in them, we're able to give them to you at very low cost and at massive scale. So really excited about all these custom chips and custom silicon things that we're doing. So the next thing, and maybe this might not be as exciting to people as it is to me, is updates to Amazon Linux and the new EC2 serial console. So I was a sysadmin for many, many years, and then I worked in support. And having an operating system that has constant updates, is predictable, is going to be patched for security vulnerabilities, it's super important. And being able to manage that and handle that at scale wherever you are, whether you're on-prem or in the cloud. It's really important. So, a lot of the Red Hat, even CentOS, were popular for that sort of use case. Amazon Linux 2022 that we announced probably, I think, last month. Now we've committed to predictable release cycles. So we're going to have new major versions every 2 years. And each major version has 5 years of long-term support. So that means we're going to be providing security patches for 5 years for that operating system. So it's based on Fedora, so it's going to get new updates and new packages a lot sooner than a mainline Red Hat-based distribution. And we're enabling SE Linux by default because we want you to be secure when you're running on AWS. And so we're building Amazon Linux with that security in mind. So really excited about this Amazon Linux. I think is, we build and manage it, and we've been using it, for years, as long as I've been here at least. And it's really going to be your best operating system to run on EC2 because we built it for EC2. You can run it on-prem or in a VM or wherever you'd like. We do support that. But if you want support for it, so if you have a problem with it, it does need to be running on AWS. But I think it's a really great option to get great performance on EC2. And then the next thing that is I think is cool, other people may not, is the EC2 serial console. And this, at least from a person who is troubleshooting a failed instance, is so useful. Because with, historically, when an instance wouldn't boot, at least a long time ago, you had to call support and they had to log into a special tool and tell you what the console output was. Then we released a feature where in the EC2 console, you could get a snapshot of what, if your instance is having problems, you can see what was on, the virtual screen of that instance. But you couldn't really do anything with it because it was literally like a screenshot that you would be getting. With the EC2 serial console, we actually give you serial access to your EC2 instance, just like if it was running in a rack in your data center and you rolled up a crash cart to it, plugged into the serial port, that's what you're going to get, and it's interactive, and you can use it, you can log into it, you can troubleshoot it. On Linux, because it's a serial console, you can actually log in interactively and figure out why it failed to boot or go in the grub configuration or whatever it is. Windows is a little bit weird, but we did build a tool that I thought I put some notes. Yeah, we called it Special Admin Console. And essentially, it lets you connect to that port and do things like access safe mode or reboot it into safe mode or safe mode with networking. So that even with Windows, where typically a serial console isn't quite as useful, we're building tools so that you can still log in and troubleshoot and update your machines, especially if, for me, especially when you're migrating from one generation to another, you don't want to completely rebuild your AMI, but you need to update drivers for networking or something like that, or for the NVMe disks. I've seen that go wrong, and you can be left in a state that you can't recover from. So that's why I think the serial console is cool and exciting. So, and then number 3, Nitro system updates. I love Nitro. I think this is one of the sometimes misunderstood, but really amazing things that we've done to innovate here at AWS. So when we launched AWS 2006, which feels like forever ago, we had just one instance type, right? It had, we didn't even give it a name. We just called it the EC2 instance. It was tiny. We guessed at what people might need. We, eventually realized that customers need more options. So we started to grow our instances and advance the virtualization. And we started with Zen as our hypervisor, and everything was para-virtualized. And then we started slowly migrating to hardware virtualization, and then PCI pass-through, and doing all these cool things. And we, we're growing pretty slowly at first, adding new instance types. This bar chart represents the number of instances that we have, and I don't know why there's not an x-axis, but that's all right. And you can see that once we launched the Nitro system in 2017, it completely changed how fast we were able to add new instances and release new types of hardware. And the reason for that is because the Nitro card it's really special because it essentially sits alone inside of an EC2 instance. It's connected via the PCI bus, and it does all of the virtualization. Here, I'll switch to the next one. And actually, I'm going to skip that slide. It handles all these virtualization functions on the Nitro card itself. So things like the network, connecting you to the rest of the EC2 network, attaching EBS volumes, doing encryption, monitoring, logging, all these things that would typically have to run inside of an agent that's running inside the hypervisor are being offloaded to a separate card. So it also allows us to essentially, we don't have to custom build, let's say, virtualization options. Like with Zen, releasing a new platform required a lot of custom development. With Nitro, it's almost as simple as plugging in a card into a new piece of hardware, configuring a couple of things for that specific hardware, and launching it from there. So it takes the time to release a new instance from, months to weeks. So Nitro, it's really great for the advancements that it gives us. But historically, we still have customers who are running on those Zen-based instances. So, you know, there are a lot of, let's say, workloads, customers who've been with us for a long time. They're using, you know, the older families. They work for them. They either don't want to rebuild or retest their applications because of the scale that they're operating at, or requirements or dependencies that they have, or maybe their operating system can't be updated to run the latest hardware. And they want to know, are we going to deprecate old generation hardware? And we don't want to do that, because if you're running on AWS and you're happy with what you're running, we don't want to disrupt your workflow. And there's some providers who are forcing customers to do that because it is expensive and difficult to run on older generation hardware, and it's inefficient for the data centers. So what we announced this week is support for Zen-based EC2 instances on Nitro-based hardware. And essentially what this does is it gives you the same experience that you're running on, you know, the previous generation instances that are based on Zen, all of the processor features, all of the paravirtualized interfaces, the messaging that you would typically have when communicating to a Zen piece of hardware that's, you know, typically would be years old. We can offer that on newer Nitro-based hardware that's going to be able to be supported for the long term. So it's a complicated process. We're doing a lot of innovation to make this happen. If you're curious about this, check out James Hamilton's blog post where he goes into a lot more detail. But it's really cool, and the takeaway is that if you're running on an older generation instance, and it's in the list of instances that are supported by Zen on Nitro, and things like the GPU instances we couldn't support because you can't really emulate a GPU. But check it out. It's great, and we want to make sure that you'll be successful on AWS for the long term. So I'm really excited about this. And number 2 is Intel and AMD next generation processors. And I kind of talked a little bit about these with like the X's, but I really wanted to have like the bulk of this be here at this point, because we've been running Intel processors since the beginning, really. We've been working with Intel for a long time. They've been building custom SKUs for us. We have very specific requirements on like power and cooling, and we want our data centers to run as efficiently as possible and give you the best possible performance. So with Intel, we've been able to do all these great things, and the newest one is the Ice Lake processor that we've launched. So we're one of the first, or we are the first cloud provider who's able to launch these in production at scale. These give you a 15% improvement in price performance compared to the previous generation instances. So if you're running on like a C5 or M5 or R5, which we really think of as like our core instances, just upgrading to the latest generation or the latest processor will give you significantly, well, at least 15% improvement in price performance. They offer an all-core turbo frequency of 3.5 gigahertz. And one of the different things that we've done this year is that the C's, the M's, and the R's all have the same processor, whereas before they were clocked slightly different, at least on the C family. And so now you'll get the same processor performance regardless of which one you choose, but the difference is going to be that memory to core ratio that I talked about earlier. These all, you know, at the non-Z or E versions have 40 gigabits to EBS, 50 gigabits for networking, and they're essentially twice the bandwidth that you have for the previous generation instances. The only caveat is that if you are coming from a previous generation instance, you'll probably have to update your network driver because the faster networking does require a different interface for the ENA network card that we have. They also support always-on memory encryption. for the memory that's sitting on the physical DIMMs. So if you want that extra layer of defense and depth, and they have memory encryption turned on by default, you don't need to do anything to be able to do that or take advantage of that. And one of the other recent and semi-recent things that we've done is enable AMD instances on AWS. So AMD instances are great because they're compatible, they're x86. Typically, migrating from, let's say, C5 to a C5A, you can get 10% cost savings at similar performance and not have to make any changes to your application. So they're a great way to save on cost without having to have a significant impact to how you're building or managing your infrastructure. And with the AMD instances, we've recently launched the M6A, which is the 3rd generation EPYC processor. The code name is Milan, if you've heard that one. These have an all-core turbo frequency of 3.6 gigahertz, also have the always-on memory encryption, and they are 35% better price performance compared to the M5A. So the Milan processor is significantly faster, more efficient than the previous gen family. So really great options for saving a little bit compared to the traditional Intel-based instances if you've been running those for a while. The other AMD instance that we've launched recently is the HPC 6A. I also came from the HPC world. These are great for applications that need lower CPU to memory ratios. They have 100 gigabit networking, support the Elastic Fabric adapter, which is great for low latency communication. Just a really great instance for many threads running at high frequency when you need to have a whole bunch of instances communicate together very quickly. So HPC 6A, cool for that. And the one I'm most excited about is all of the new AWS custom designed silicon that we've launched over the last week and or year. And the first one is the Nitro SSD. So we've had SSD-based instances for quite a while. Typically, they've run commercial SSDs from brands that you've probably heard of. But they weren't exactly fitting our needs. They're general purpose SSDs, which mean they have to support customers running all sorts of different hardware configurations. And they weren't giving us the consistency that we needed in terms of latency and also things like firmware updates and the type of work that, or let's say the very specific requirements that we have for performance and reliability. So we've designed and are now using or now have available these Nitro SSDs in some of our newest instances. And like even our previous generation Nitro powered, let's say, SSD-based families, they do have data automatically encrypted at rest, which is great for that. And these are available coming soon in the i4i instances. So these also have that latest Intel processor. They have the Nitro SSD. The i3 family, which they're replacing, is a couple years old at this point. So upgrading to the i4i, you're going to get significantly better performance from both a processor and an SSD standpoint. So they say 55% better compute price performance than the i3s, and 60% lower latency and 75% reduced variability in the access to the SSD itself. So one of the things that we find is, especially with very demanding applications, that long tail of latency, when you start to get little spikes, by smoothing that out, you can improve your overall application performance. They're great for databases, analytics, anything that requires lots of random I/O from a SSD. And then I want to talk about Graviton 2. So Graviton is a really cool processor. So it's ARM-based. We developed it internally. We've been iterating on it for years. It's available in most of our instance families. So we have, let's say for the M's, we have the M family in Intel, AMD, and Graviton flavors. And it has great support across, most applications, especially in the open source space, but also commercial applications are becoming more compatible with ARM-based processors. And they offer significantly better price performance. So with Graviton 2, up to 40% better. And today, with Graviton 2, we launched the first generation Graviton in 2018. Current one we launched a couple of years ago, had 4 times as many vCPUs, significantly better performance, 30 billion transistors, and it's much, much faster. So this is really the heart of Graviton. You'll see it in a lot of instances. It's great for price performance. And we've seen customers really across every use case adopt Graviton and see the benefits that you get from it. Migrations usually happens, people start with small, recompile their applications, or just run, especially if it's an interpreted language, on Graviton, and they see a lot of success, and it's easier than they think. And with that, with Graviton 2, we offer them in the, along with the Nitro SSD, in the IM4GN and IS4GEN. And instance name aside, essentially the IM4GN is going to be a Graviton-based instance for that high random I/O. And the IS4GEN is also Graviton-based, also uses the Nitro SSD, but is more for like the dense storage. So it has a much lower cost per terabyte. It's not built as much for random I/O, but more streaming. So if you have databases, real-time databases, stream processing, log analytics, things that are rolling, sequentially, the IS4GEN is going to be the right choice for it. And the last thing I'm going to talk about, with just 3 minutes left, is Graviton 3. And we just announced this week. I'm excited about it. We've got 25% better performance, just kind of all up with the Graviton 3 processor. But what's really interesting is that these very specific operations like floating point operations and cryptographic and machine learning are double or triple the speed. So if you're using, more, let's say, scientific or math-based applications, Graviton 3 is going to be really cool for you. It also is going to be the first instance in the cloud with DDR5. So memory streaming is going to be blindingly fast. So memory-bound applications, I think, are going to see a huge benefit. Also, when it comes to sustainability, Graviton 3 is far more energy efficient than Graviton 2. So we're starting to release more data about the energy efficiency, the, let's say, watts per operation or clock. And I don't have those numbers off the top of my head. But Graviton 3 is going to be great for that, or even better, and is going to be the best option on AWS for that low impact. And it's going to be available on the C7G family and offer all those cool things that I talked about. So that's it. We've done a lot of updates. We have a lot of new instances. We have a lot of new capabilities. Definitely check it out. If you have any questions, feel free to ask me. Moving forward, reach out to me via email, LinkedIn. I'm going to hang out here after the talk. You can come up if you have any questions about any specific instances. I know I couldn't go in depth on everything, but we sadly only have an hour together. So I appreciate your time. Thank you all for coming, and hope you have a great rest of the conference.